We will begin respiratory physiology by examining the phases of pulmonary ventilation. So pulmonary ventilation, which is also known as breathing, occurs in two phases. We have the inspiration phase and the expiration phase. The inspiration phase creates airflow into the lungs, whereas the expiration phase creates airflow out of the lungs. Just like with blood flow, pulmonary ventilation is a mechanical process that's driven by muscle contraction. In this case, skeletal muscles surrounding the lungs are going to contract or relax to move these volumes of air. This mechanical process of muscle contraction is going to create volume changes. These volume changes will lead to pressure changes, and pressure changes, just as we saw with blood, are going to create flow. This diagram shows us the skeletal muscles that are involved in both inspiration and expiration. We'll examine the muscles of inspiration first. So quiet inspiration, that is, breathing that occurs during times of rest or times of limited physical activity, involves contraction of two muscles, the diaphragm and the external intercostal muscles. The diaphragm muscle, when it is relaxed, is dome-shaped, and during contraction we see that the diaphragm flattens out, which is going to increase the volume within the thoracic cavity. As we will see soon, this increase in volume is going to decrease the pressure for a brief time and create airflow into the lungs. The external intercostals, on the other hand, function to elevate the ribs. So notice here that the direction of the arrows is indicating the direction that the muscle pulls when it contracts. The elevation of the ribs is also going to serve to increase the volume of the thoracic cavity. So during inspiration, the inspiratory muscles, so like the diaphragm and the external intercostals, are going to contract, which are going to increase the volume of the thoracic cavity. And in doing so, the lungs will be stretched and intrapulmonary volume will increase. The intrapulmonary pressure, so that is the pressure within the lungs, will drop when the volume increases. We'll see that it falls to 1 millimeter of mercury below ambient atmospheric pressure, which is what the negative sign is going to mean in this context. So because the intrapulmonary pressure briefly drops below atmospheric pressure, that's going to create airflow into the lungs. We see that forced inspiration is what occurs during things like vigorous exercise, or if COPDs, that is chronic obstructive pulmonary disorders, are present. So forced inspiration is going to recruit additional muscles, so for example the pectoralis minor muscle, as well as the sternocleidomastoid muscle, which will help to further expand the volume of the thoracic cage when those muscles contract. So changing gears, we will now examine what occurs during expiration. So during quiet expiration, the diaphragm and the external intercostal muscles are going to relax. Because these muscles are relaxing and not contracting, that means that quiet expiration is considered a passive process. This causes the volume of the thoracic cavity to decrease when they relax, allowing the volume of the lungs to decrease as well. We also see that intrapulmonary pressure, so again that pressure within the lungs, is going to rise when the volume decreases, and it's going to rise to about plus 1 millimeter of mercury above ambient atmospheric pressure. This positive pressure is going to cause air to flow out of the lungs. So again, quiet expiration is typically a passive process because it results from the relaxation of the diaphragm muscle as well as the external intercostals, which when they relax are going to decrease the volume of the thoracic cavity for a brief time. It is also passive because the elastic fibers within the lung tissue itself are going to recoil and return the lung to its original shape prior to inhalation or inspiration. Forced expiration, on the other hand, recruits several muscles to contract and further decreases the volume of the thoracic cavity during exhalation. So forced expiration, just like forced inspiration, would also occur during things like vigorous exercise or if COPD conditions are present. The muscles that are recruited during forced expiration are the oblique muscles, the rectus abdominis, as well as the internal intercostal muscles. So we see that the internal intercostals, the external oblique, the internal oblique, and the rectus abdominis muscle are going to decrease the volume of the thoracic cage when they contract because they all pull the ribs downward when they're contracting. So these muscles are only recruited during forced expirations. So here we can put it all together. So let's examine the pressure changes during inspiration and expiration and see how those changes correspond to creating airflow, either into or out of the lungs. So if we examine the tracing for intrapulmonary pressure, that is the tracing in pink, we see that during inspiration or inhalation, the pressure becomes negative for a brief time, dropping to about 1 millimeter of mercury below ambient pressure. This change in pressure is due to the expansion of the lungs as well as the thoracic cavity, which is going to create airflow into the lungs. So as air fills the lungs, the pressure rises to 0 millimeters below ambient, meaning that the pressure in the lungs is equal to atmospheric pressure. So anytime we see that the pressure is equal to 0 millimeters of mercury, that implies that the pressure in the lungs is equal to the atmospheric pressure. We said that the opposite occurs during expiration. Or exhalation. The diaphragm and the external intercostal muscles relax, decreasing the volume of the thoracic cavity as well as the lungs, and this causes the intrapulmonary pressure to rise, increasing it briefly to plus 1 millimeters of mercury above ambient pressure. So this change in pressure, again, is what creates the airflow that's going to push the air out of the lungs. So due to the presence of the fluid that's in the intrapleural space, we see that the fluid also creates a pressure that's causing the walls of the lungs to adhere to the walls of the pleural cavity. So therefore, any expansions or compressions of the thoracic cavity are mirrored by the lungs due to the sticking of the lungs to the pleural membrane. So think of it this way: the surface tension that's in the that's created by the fluid in the intrapleural space causes the lungs to stick to the wall of the thoracic cavity like flypaper. So here we see that a typical intrapleural pressure is about -6 millimeters of mercury below ambient. So if that pressure were to further decrease to, say, -8 millimeters of mercury below ambient, that would mean that the volume of the breath would increase as a result of that.